Hi, I'm Henry Segerman. These are braiding gears. So there are 3 gears. They gear into each other and they actually hook onto each other so they don't come apart even though there's no axles, there's no frame. These 3 gears stick together. So this is similar to, and it's derived from, gripping gears, which I made with Sabeta Matsumoto and Will Segerman. So these have the same property, but there's only 2 of them. They hold together. I'll put a link to the video in the description. So what's different about these? Well, obviously there's 3 of them, but there's something else going on here, which is that if I keep rotating in one direction, say to this point, then I can break them apart in a different direction. So before I had the purple in the middle, and now I've swapped the positions of the purple and the red. The red is now in the middle. And I can keep going, and then I can make the blue be in the middle instead. And in fact, you can get any permutation of the 3 gears that you like. You can just keep rotating it around, and you can actually choose at this point here, it's got 3-fold rotational symmetry between the 3 gears, so you can break it apart like this, or you can break it apart like this, or you can break it apart like this, and it always holds together. Let's actually make a braid with the braiding gears. So I've attached these pieces of yarn to some of the arms of the red, blue, and purple gears. And then if we do the motion, then the yarn gets tangled up in the right way. Here I'm making the standard braid, but you can make any 3-strand braid you like just by changing how you permute the different gears. So let me say something about how this works and how it achieves these 2 properties. One, that it stays together, they don't come apart, except that they do. When you come to this point, you can swap around how they're connected to each other. So each of the 3 parts is just a solid. Well, it's 2 pieces of 3D printed plastic that are bolted together. So it's 3 rigid bodies, and there's sort of 4 layers in each half of the gear, and let's call those layers sort of 0, 1, 2, and 3. So layer 0 is the one that has these grooves in it. And layer 1 has the pegs that sort of points down and hooks into the grooves on the other gears. So that's essentially the same mechanism as with the gripping gears. So these only have layers 0 and 1. These ones also have some stuff in the middle to keep it from sort of twisting out of the way, which is not necessary for these ones because of all of this extra stuff that happens to be around. So layers 0 and 1 are what's actually sort of stopping it from coming apart when it's connected. What are layers 2 and 3 doing? So the real purpose of layers 2 and 3 is to keep the outer 2 gears in sync as they go around the inner gear. So let me try and explain why that's necessary. So if we get to this position, this triple point, then the purple gear can detach from the red gear. So why not, when I'm in this position, let me just roll the blue gear out of the way down here somewhere, and then I can roll the purple gear up to where it was, where it could detach from the red gear, and then I could just take the purple gear off and everything would fall apart. And so why isn't that possible? Well, if I try to do this, if I try and move the purple gear up around the red gear, the blue gear is forced to get into the right place to catch the purple gear as it comes to this point where the purple gear can detach from the red. So that's what the things on layers 2 and 3 are doing. You know, if I try and sort of move the purple gear up here, you can see this thing up here is pushing against this part of the blue gear, and then a little bit later something else gets in the way. There's actually there's different stuff happening on the bottom. Maybe I can show that. So here, purple is pushing against this blue bit here, and then, well, what else is happening? So let me slowly turn it over. Purple is trying to go this way, which is trying to go this way. So the next thing that happens is that this purple bit pushes this blue bit, which again forces it up, and then Now this purple bit is pushing this, so there's this sort of big sort of choreography of the different things on layers 2 and 3 that are sort of getting in each other's way and stopping me from moving the purple gear up to the place where it can detach from red without blue being there to catch it. Could you do this with 4? That's the sort of obvious next question. Could you come up with a mechanism which had 4 gears where again you could sort of permute them any way that you wanted, and they would always have to be held together? Maybe you could do something which had 4 gears sort of that would form into a square which you could break apart in any way. You'd have to redesign how the grooves are put into these, because this is specifically designed for 3 gears. But the real question is, how do you arrange it so that you can permute any 2 rather than sort of in a cycle? And that I don't really see how to do with rigid bodies. Maybe something with internal mechanisms, you could do something like that. But I don't see how to do it with just rigid bodies. I would have liked to be able to have the outer 2 gears directly gear into each other rather than, there's a little bit of slop here, but that just doesn't seem to be quite possible. There's enough sort of traffic going on around in the various layers that you can't really make any of these pieces any bigger to try and get it to gear better. So it has this sort of bit of slop, but it's sort of interesting. As you get closer to the triple point, the slop kind of gets eaten up. Somehow it gets funneled into, so here there's really no slop at all. And so when it's near the threefold rotational symmetry point, then it's very stable. So anyway, this is braiding gears. Thanks for watching.